So this question tells us that a car is driving up a hill and it runs out of gas and it begins to coast down the hill and goes down the embankment onto another part of the hill. And this is where it stops. And it wants to know the total height at which it was able to reach based on the distance that it moved. So, in order to solve this question, we have to know the amount of potential and kinetic energy that the vehicle had at this spot in order to find the height. Because as the vehicle, as it's here and as it moves down, it has different amounts of potential and kinetic energy. So in order to solve for this, we know the velocity is 20 meters per second, the mass of the car is 750 kilograms, and the height here is 5 meters. So we can start with potential energy, or with kinetic. It doesn't matter which one you start with in this situation, because in the end, what we have to do is we have to add them together to get the net energy. So with potential energy, the formula for that is mass times gravity times height. So we multiply those three things together, all of which are knowns. Kilograms cancels, we get Newton meters, which is joules. And so this is our value for potential energy. Then we move on to kinetic energy. And the formula for that is 1/2 mass times velocity squared. We plug those values in, and we get 150,000 joules again. So we will take these two values, the potential and kinetic energy, and we add them together to find the total net energy at that spot. Now we need that value because whenever we go to solve for the height, we need to know the total net force in this part of the equation, and we need to divide it by the mass times the gravity. Now whenever we do that, we have this value in joules, and joules is just Newton times meters. And then we divide that times the mass, which is in kilograms, and times gravity, which is newtons per kilograms. So the kilograms in the denominator cancel out each other, and then the newtons in the numerator and in the denominator cancel each other out. So we're left with the height in meters, which turns out to be 25.39 meters.